So the only time that you have to worry about there potentially being two triangles that exist from the given information is whenever you are given a side, and an angle. So for example, if you're given like angle alpha is 30 degrees, side A is 6, and side B is 7. So I always like to draw out just like a random triangle, right, to label and double check what case that I'm given, and to give me a visual to determine whether or not like I should be using law of sines or law of cosines, right? Because you're either going to have to use law of sines or you're going to have to use law of cosines. For this particular triangle, so if we have alpha is 30 degrees, the side opposite alpha is 6. This is beta, gamma, and then we know side B is a length of 7, and we don't know side C. So you can see we know side, angle, SSA, or if it helps you remember this case, the ASS case. This is the ambiguous case. And what it means is that from the given information, you can have one or two triangles. It also means you could technically have no triangle that exists. I'm just not going to give you any problems where there's no actual triangle that exists. There would either be one or two. So we talked about in our notes, like the different cases of analyzing the given information, how you could determine whether there's one, two, or no triangles that exist. It's also in your textbook, or anytime that you have the SSA case, you can always just test for a second triangle. So for the SSA case, you always end up having to solve for an angle first. So the angle that's opposite one of the given sides. So in this case, we would have to solve for beta, angle beta first. So setting up our law of sines, we would have sine of beta over 7 equals to sine of 30 degrees over 6. And we're solving for beta. So really this is an equation, right, with sine, and we're solving for the unknown angle. So we can multiply by 7 on each side. We'd get sine of beta equals to 7 sine of 30 degrees divided by 6. And we're going to use inverse sine to solve for one of the possible values of beta. Now, if we look closer, the right-hand side represents a ratio. Sine of 30 degrees is a positive ratio, right? Because 30 degrees is from quadrant 1. And then we have positive 7, positive 6. So this ratio is positive. Therefore, when we take the inverse sine of this positive ratio, it's going to represent an angle from quadrant 1. And that's always going to be the case. Inverse sine, because think about the range of inverse sine is negative pi over 2 to pi over 2, or negative 90 degrees to 90 degrees. So because it's the inverse sine of a positive ratio, it's always going to represent an angle from quadrant 1, an acute angle from quadrant 1. However, sine is positive in quadrant 1 and quadrant 2. So there is a quadrant 2 solution to this equation. There is a quadrant 2 solution to that equation. And angles of triangles, right, just have to add up to 180 degrees. So you can have an obtuse angle for a triangle. Anytime we solve for that first angle, we're always going to get an angle from quadrant 1. We could determine the angle from quadrant 2 that would also be a solution to that equation and could potentially create a second triangle with the given information by taking the angle that we just found, and subtracting it from 180 degrees. So your potential triangle 2, this would be all your work for triangle 1. Your triangle 2 could potentially have an angle beta, which that's where I call it beta sub 2, and I treat this as beta sub 1, where beta sub 2 would be 180 degrees minus beta sub 1. So minus the inverse sine. You can write beta sub 1, or I'm just going to write this out, minus inverse sine of 7 times sine of 30 degrees. This is where I told you guys to store in your calculators to make it easier. This angle will be an angle from quadrant 2. This angle, the angle from quadrant 2 needs to make sense with the given information. So with that given angle, meaning you have to be able to solve for a third angle in the second triangle for the second triangle to exist. So let's see what the approximations of these two values for beta are. Let me open up this. So we would have, and I'm in degree mode, so we would do inverse sine of 7 times sine of 30 degrees divided by 6. Okay, so that ends up being approximately 35.685 degrees. And then if I store that, store angle, I'm going to store it under B. Okay, so then we can do 180 minus that angle that I stored in B. And we get beta sub 2, or beta from the second triangle, is 144.315 degrees. And basically, there will be a second triangle if we go to solve for the third angle, gamma, which would be 180 degrees minus the sum of the other two angles, so minus 30 degrees plus beta sub 2. And I should store this. So beta for the second triangle I should store as well. I'm going to store under A. So if I do 180 degrees minus 30 minus beta sub 2, I get approximately 5.685 degrees. That means there is a second triangle. So we could go back to triangle 1 and we could finish solving. So we could solve for gamma sub 1, right? And we could just do 180 degrees minus 30 degrees plus beta sub 1. And you continue solving for, we need side C then, for both of those triangles. Now, if a second triangle did not exist, we would get a negative angle for the third angle in triangle 2. Meaning that that angle from quadrant 2 wouldn't make sense with the given angle. So that's why for the SSA case, if you're given, even if it's the SSA case, if you're given an obtuse angle, the one angle that's given is obtuse, it won't make sense for there to be a second triangle, right? Because you already have the quadrant 2 angle. Any triangle can only have one, at most one quadrant 2 angle, one obtuse angle. However, if you don't want to think too much and you're just like, oh, SSA, I just want to test for a second triangle, that's fine. Or if you remember that when you're given an obtuse angle, there's not going to be a second triangle, that's another thing that you can remember. So for example, if, let's say that you have alpha is 102 degrees, side A is, 10, side B is 6. Okay, so this is again the alpha, the SSA case, right? We don't know beta, we don't know gamma. B is 6, A is 10. Okay, so we'd have to solve for beta again. So we'd have sine of beta over 6 equals to sine of 102 degrees divided by 10. So we'd get sine of beta equals to 6 times sine of 102 degrees divided by 10. And then again, when we take the inverse sine of this ratio, this is going to be a positive ratio. Therefore, this is a quadrant 1 angle. We know that because the given angle is obtuse, there's not going to be a second triangle. But if we didn't recognize that and we went, oh, let's just test to see if there's a second triangle, we would do, okay, beta sub 2 is 180 degrees minus beta sub 1. That would end up being, let's see, what would that end up being? So that would be 180 minus the inverse sine of 6 times sine of 102 degrees divided by 10. Okay, so we end up with 144.063 degrees. Well, that doesn't make sense with the given angle of 102 degrees, right? So there's no second triangle. And that's what it looks like if there fails to be a second triangle, is the angle, the quadrant 2 angle that you find doesn't make sense with the given angle. And it doesn't have to be a given obtuse angle. Sometimes there can be no second triangle even with a given acute angle. You just have to test. Hope this helps.